Hello there. In this video we're going to be learning about sketching quadratics. Now a quadratic, if you didn't already know, it either looks like this here. It's either a U curve or more of an N curve, or you could see it as a smiley face or a sad face. That's how what quadratic curves look like. So for example here, we have this quadratic. Obviously, it would be a smooth curve, but because of my poor drawing skills, it is quite choppy, but this should be a smooth curve. Now, there are a few features in every quadratic curve that we can point out. The first one is the shape. As I've already said, it can either look like a U or an N, or a smiley face or a sad face, right? So this one, the shape is a smiley face, right? So we've got the shape. Now the next thing is the roots, or are the roots. Now the roots of this quadratic function, or any quadratic function, is when it crosses the x-axis. So you have these two. Right, so this is a root, and this is a root as well. So from the graph, we can tell what the roots are. So our roots, in this case, here we have -3, so our roots are -3, and we have a root here, 1, so it's 1. The next thing is the intercept, and the intercept is where it intercepts the y-axis. You can also call that the y-intercept. So in this case, the intercept is -3. And finally, we have the turning point, which is this point here. It's either the minimum if it's a smiley face, or if it's a sad face, you can see that it would be the maximum. It's just a point where it stops going one direction and starts going the other direction. So this is the turning point. And this is the intercept. Okay, so the turning point. In this case, if it was on graph paper, you'd be able to calculate it accurately. In this case, let's say it's -1, -4, like that. Okay, so now let's move on to the opposite process. So this process is just looking at the graph and being able to identify where it crosses each of the axes and where its turning point is. And also what shape it is. But now let's try sketching it from an equation. So here we have a quadratic equation, and we have our axes here. Just bear in mind it says sketch, and sketch means it doesn't have to be not precise, I'm gonna say. I'll show you why later. If it says draw, that's when you have to be accurate, but I'll show you what I mean later. Okay, so first off, let's figure out what the shape is. How do we do this? Well, we look at, remember when I said that the quadratic form is the same as saying ax squared plus bx plus c, where a, b, and c are just numbers. So a in this case would be 1, 1x squared, b would be 2, and c would be -3, like that. So the shape of the curve is determined by a. So, I actually do this in red. If a is greater than 1, then it's a smiley face. If a is if a is greater than 0, it's smiley face. If a is less than 0, then it's sad face. If you think of it, it's like if A is positive, you're happy. smiley face. If A is negative, you're sad. If that's a good way of remembering. Like that. So for example, in this case, our x squared term, that's basically it. If the x squared term is positive, we have a u. If the x squared term is negative, then we have an m. So a equals 1. So a is greater than 0. So we have a smiley. Okay, so we're done with the shape. Next, let's look at the roots. Now, let's think about where the roots are. So the roots are just where it touches this x-axis down here. But the thing is that at any point on this x-axis, y is equal to 0. Because remember, this, at any point here, this line, y is always equal to 0. So, for this, the rule of finding the roots is we set y equal to 0. And then what will we get in this scenario? Well, we'll get x squared plus 2x minus 3 equals 0. All I've done here is this y, I've set to 0, and I've switched the places. So this bit comes on the left of the equation now, which doesn't change anything. But this looks very familiar because we know how to solve quadratics in this form. So what we can do is we can find two numbers that multiply to give, so factorize it out. So we have two numbers that multiply to give minus 3 that add to give 2. This minus here tells us that we need one positive and one negative. And if you think about it for a bit, you'll probably come to the conclusion that it's 3 and minus 1. And now we can put it into our factorized form. And remember, this is still equal to 0. And then we can do what we said last time, which is for this to be equal to 0, one of these has to be equal to 0. So either x plus 3 equals 0, or x minus 1 equals 0. We can manipulate the equations here to get x equals minus 3 and x equals 1. So these are our roots, and we can actually put these on the graph, like so. Now, you can see now there's a relation between solving the quadratic and how it looks on the graph. So your solutions of the quadratic are always what your roots. So your x, the intercept with the x-axis. Now let's find our y-intercept. This follows the same kind of rule. We want to know where it crosses the y-axis. Now, along the y-axis, x is always 0. So now we can just, instead of setting y to 0, we can set x to 0. And see what we get. So now, what we get up here, so we get y equals, and now x squared becomes 0 squared. So just making x equal to 0. And we have plus 2, and then the x turns into a 0 again, and then minus 3. Like so. And the 0 terms cancel out, so we just get minus 3. And just a general rule, the intercept of a quadratic, or the y-intercept, is this plus c bit. So in this case, it was minus 3. So we got minus 3. So we can also put that in here. Okay, so now how do we find the turning point? Well, there is one method which we can use, which is because this quadratic is symmetric. So, for example, if this isn't my final sketch, but if I did something like that, this would be symmetric on either side of the turning point. So if we found this middle bit, which is in between the two roots, we can figure out the turning point, right? So what we can do is the midpoint between 1 and -3 is just, all you have to do is add them together, like that, and divide by 2. So 1 plus -3 is -2 over 2, so we get -1. So we know this point is -1 here. And then all we need to do is we need to substitute it into this equation so we get the y value. So we put it in, so we get y equals -1 squared plus 2 times -1 minus 3. And -1 squared is 1. This goes to give -2, and then we have -3, like that. And that comes out to give -4. So our turning point is -1, -4, like so. So this would be -4 here. There is also another method, and that's higher. And I'll talk about that in the next video. Okay, so I'm just gonna quickly erase this. And I'm gonna draw the final one. Whoops. Okay, so now we know all our different values. So what we're gonna do is I'm gonna put in the turning point here. I'm gonna try my best to draw a smooth curve that goes down, hits the turning point, and then changes direction. Goes through all of the points. So it goes through the two roots and the y-intercept. And I'll take these further like that. And I can even label this as -1, -4. Now, I'll go back to this where it says sketch. So it says sketch, so we don't need to put in like -2 or here, put our values or whatever. We don't have to do that. We just have to put the intercept. Just give all the information. So the shape should be the same, which now we can check, and it is the same. And just to put in our roots, our y-intercept here, and our turning point. Okay, let's try this one. Now the shape is, let's start with the shape. Now you can see that our A, remember our A isn't this, because our A comes before the x squared term. And because it's negative, we know it's that shape. Okay, so now for the roots, let's set y equal to 0. And then that'll give us 8 minus 2x minus x squared equals 0. And if you remember from the last video, we can swap the signs. So if we multiply everything by -1, we get x squared plus 2x minus 8 equals 0, because 0 times -1 is still 0. And now we can factorize this. So let's start. Let's find two numbers that multiply to give, -8, that add to give 2, like so. Well, again, you can pause the video and think about it. Okay, it comes out to be -2 and 4, like so. And now we can put it in our factorized form, then say either one of these equals 0, and then we can manipulate the equation to find our two values. Okay, and then we can put those in, so we have -4 all the way over here and 2 around about here. Now let's find our y-intercept. Let's set x equal to 0, or we can just use the fact that it's c. So we get y equals 8. And then we can put that there. And then we have our turning point. Again, let's add our two roots and divide by 2 to find the midpoint. So that'll again go to give minus 2 over 2, minus 1. Okay, and then we just put that value in, x equals minus 1, into this equation up here. So we get y equals 8 minus 2 times minus 1 minus minus 1 squared. Again, the 8 stays the same. 2 times minus 1 is minus 2, but we have a minus here already, so we get minus minus 2. And then here, minus 1 squared is just 1, so we get minus 1. The minuses cancel out to give a plus, so we get 8 plus 2 minus 1, so we get 9. So actually, it would probably help to move 8 down a bit here, so we stay on the axes. Oops. I'll just delete it. We'll move the 8 down a little bit, and then so we have room for the 9. Now, you need to make sure that this isn't your turning point. You don't do something like this, or whatever. You want to make sure 9 is your turning point. I'm going to also move these a bit closer, like so it looks more like what you're familiar with. Okay, so we want this to go through both of these. At minus 1, we want this turning point. So it's here. And then we go back through those. Okay, and we can put minus 1, minus 9. Sorry, not minus. Just minus 1, 9 as our turning point. And we can also put it here. And there we go. We've sketched one that looks like a sad face, and we can check it here to see if we've got the right shape. Okay, great. I forgot to mention that this is the same quadratic curve as this. I've just shown how we can go from the equation to the graph, and how we can get all these different bits of information from looking at the graph. Okay. Here are some exercises for you to have a go at. And I will see you in the next